Hello and welcome to the raycasting tutorial. In this video, you'll be learning what a raycast is and how we can use raycast actions in Playmaker. What is a raycast? A raycast is a podcast created by someone named Ray or Raymond. Raycasts are available on most streaming services, but because of legal reasons are not available in all countries. There's another kind of raycast, which is like a laser that gets shot out of a game object and then detects it if it hits something, and then can tell you what it hit and other information about what it hit. In other words, it's a ray that is cast out into the game world. Games use this for things like shooting and detecting whether something is visible or hidden. Let's build one together so you can see how simple this tool is and how powerful it can be. We could start by creating a sphere, a cube, and a capsule. Spread them out so that the cube is between the sphere and the capsule. And make sure that if you have your sphere selected, that its blue z-axis is pointing at the cube. If it's not, just rotate it so it is. Then add an FSM to the sphere. In the first state, add a raycast action. Now, just to give you an idea of how this thing works, let's just check this debug option down here. This will allow you to see the actual ray being cast from your game object. So press play. Whoops, nothing happens. Okay, so stop the game. Go to this direction value and put 1 in the z-axis. This means the ray will be cast out in the positive direction of the z-axis, which is another way of saying it will project forward out of the game object. Now press play. And look at that. The yellow line is your ray being cast. Notice that the raycast is only visible in the editor window and not in the actual game. That's why the option to see it is called debug. Okay, so what now? What can we do with this raycast? Well, right now the ray is just being shot out and just going through everything. So let's go over some of the things this action does. In this result section, the first thing we have available is a hit event. Let's just go ahead and make a new event. Call it object was hit. And we'll create the transition, send it to a new state. We'll call this new state object was hit. If you press play, you'll see that as soon as the game starts running, our FSM goes off to the object was hit state. That's because the raycast hit the cube. Let's turn off that hit event just by changing it back to none for now. The next thing we can try out is store did hit, which returns a bool value telling us whether or not it hit something. Try it out by making a new variable called did hit. Now when you press play, you'll see that as long as the cube is in front of our sphere, it will return the value as true. If I go ahead and lock our Playmaker editor so this window stays when we select another object, and then I select this cube, keep an eye on this did hit bool value when I move the cube away. It still says true, but now that's because it's hitting the capsule. But if we move the capsule as well, you'll see that the bool returns as false now. Next on our list is store hit object. Whichever game object was hit will be stored in a game object variable here. We can create a new variable and call it object hit. And when we press play, you'll see that it's showing our cube. And when we move the cube out of the way, it shows the capsule. Let's take it back a little bit. Up here, there is this option for distance. Currently, it is set to 100. That's why the raycast just shoots out further away than we can even see, and it has no trouble hitting and returning information on objects right in front of it. But if we spread our objects apart a little bit more and change this distance to something like 2, then press play, you'll see that the raycast does indeed stop at 2 meters. As I adjust this value, the raycast grows and shrinks up here in the editor window. Okay, let's set that back to 100 for now. Down here we have store hit point. This allows you to store the exact point in space where the raycast hit. This information is stored in a vector3 variable. Let's create a new variable called hit point. Now when we press play, if you move the sphere up and down, you can see the vector 3 changing. When I move it up, the y-axis number goes up. When I move it down, the y-axis number moves down. When I move it higher than the cube and it hits the capsule behind it, you'll see the z-axis jump from, let's see, goes from negative 0.3 to 0.7. You can imagine how simple it would be to use store hit point with a set position action to put bullet holes on walls and other such common mechanics. Down here in the filter section, we have options for layer masks. Setting layer masks is a way to tell the raycast which objects to pay attention to and which objects to ignore. Say, for example, you wanted it to ignore walls and only return information on NPCs, or the other way around. In the layer mask value, you can enter how many layers you want to choose from. For this example, let's just put 1. Now in the element down here, if we click this little drop down, we can go down here to add layer. This will take us up to the layers in our inspector. Now I already put it in here, but you should not have this, so you could type it in on your own. It doesn't have to be in this same order. You could put this layer as whatever number you'd like, but just type in can be hit. That's what we'll use for now. Now if we go back to our FSM, we can set this layer as can be hit. So what this will now do is only interact with things on the can be hit layer. We just made that layer right now, so there's nothing on it yet. So I'm just going to select our cube, and over here in the inspector under layers, I'm going to put it under can be hit. And now if we press play, our cube is getting hit, and so it's showing up. But when we move it out of the way, our capsule does not get hit because it's not on the can be hit layer. So the information we get is from the last moment the raycast was actually hitting something, which was our cube. So that's why it still says cube. Now if we stop this and go down here to invert mask, with that checked now, if we hit play, we get the opposite effect. Our cube is completely ignored, and instead our capsule is being hit. This entire time, we've seen how this raycast action can only return information for one object at a time, but what happens if you want to get information on every game object the raycast is passing through? That's where the RaycastAll action comes in, which is nearly the same as the raycast action, but let's grab one. I'm going to delete our old raycast, throw in a RaycastAll action. We can see that we have the option to store multiple game objects in an array. Right here under Store Hit Objects. If you hover your mouse over it, it says Type Array. Store the game objects hit in an array variable. So if we set this direction to forward in the z-axis, store all the objects in a new array called All Objects Hit. Turn the debug on so we can see our array and press play. You'll see that it returns both our capsule and cube. In this video, we learned that a raycast is like a laser being shot out into the world, and that with raycast actions, we can get information like which objects were hit, if anything was hit at all, and exactly where in space the hit occurred. Be sure to check out our other videos to learn all the various features of Playmaker. Links to more learning resources are in the description.